Hello and welcome back to the 8.4 video on hypothesis testing for a single proportion. We're dealing with qualitative data, so just reminding you of that. And when I say qualitative data, I'm going back to day one, week one, when we talked about questions, data when you ask somebody a question like a yes, no, or like raise your hand for the number of people that have brown eyes, or raise your hand for the number of people that have 4 siblings. You're going to count those people and then divide by the total. So remember that p hat is x divided by n. Okay. So right here, our sample proportion, x divided by n. So we're going to be using a test statistic that is a z-score. This is our test statistic. But other than that, it's going to be a little bit different program, set up the same in Desmos. I'm going to show you how to use that. And our 6 steps are going to be identical to what they were in 8.3. So let's jump right in. Example 1 says, a teacher believes that 85% of students in the class will want to go on a field trip to the local zoo. She performs a hypothesis test to determine if the percentage is the same or different from 85%. The teacher samples 50 students and 39 reply that they would want to go to the zoo. For the hypothesis test, use a 1% level of significance. First, determine what type of test this is, set up the hypothesis test, find the p-value, sketch the graph, and state your conclusion. Be sure to label all 6 steps. So, first of all, we have to go through and decide what symbol are we using. Means, which is mu, or p for proportion. Because we're talking about percents, we're talking about p. The H0 is always an equal to, and it's what they think is already true. So that would be the 85%. But she wonders when she does her sample if it's going to be the same or different. So that means we're doing a not equal to 85%. So that's a two-tailed. So when we look at our graph in step 4, we're actually going to have 2 shaded areas. Okay. So make sure you shade the 2 spaces. So our step 2 is our alpha. This time they want us to use a 0.01% level of significance. And now we're going to find our test statistic, which is a Z0, which is the p hat minus p over the square root of PQ divided by N. And that's going to come out of our program. You can calculate it if you want to, but our program will give us that. So let's just go ahead to our program and put in our information. Our p hat, the program in Desmos will calculate this, but if you want to look at it ahead, it's going to be x divided by n. And so that comes out to be 0.78. So this would be 0.78 minus the 0.85 divided by the square root of. Notice this p and q is not from the p hat, it's the p 0 or p that we think is true. So it's 0.85 times 1 minus 0.85 divided by n, and n would be 50 in this case. Okay, so we're going to go to the program and it's going to give us the p-value, and then we're going to compare that to alpha, which is 0.01. So let's do that. You can also click on this Desmos there's a link in Canvas for this program for Desmos, which I recommend that you do, and then save your own and call it proportions. So we're going up here. I entered 50 for my n. I entered 39 divided by 50, or you could just put the proportion. It's up to you. We're testing it against 0.85. Our alpha this time is a 0.01, which we really only need to do if we're doing a confidence interval. There is our test statistic. It's a negative 1.38. And then we're doing a two-tailed. So notice there's the greater than, the less than, or the exclamation mark is the two-tailed. So if you open that up, you're going to go down and there is the p-value. It's 0.1657 when you round to 4 decimals. Let's go back to our paper. So we have our p-value. Now remember, our p-value kind of covers, when it's a two-tailed, we're kind of saying it's kind of in this space here because it's a two-tailed. So our p-value compared to our alpha, this time it's greater than our alpha. And so we do not reject, we do not, I wrote it weird, do not reject H0 because our p-value is bigger than our alpha. It's very likely that this could occur. Okay, so there is not sufficient evidence. Is not sufficient evidence to say that the proportion of students who want to go to the zoo is any different than 85%. Not enough evidence to say it's any different than 85%. And the reason I said any different is because the teacher said same or different. So it was a two-tailed test. It wasn't a greater than or a less than. Let's look at example 2. So example 2 says, marketers believe that 92% of adults in the US own a cell phone. A cell phone manufacturer believes that the number is actually lower. 200 American adults are surveyed, of which 174 report having cell phones. Use a 5% level of significance. State all these pieces, but really it's labeling all 6 steps. Okay, H0 and HA. We have percentages, so it's a P. H0 isn't equal. They think it's 92%. Manufacturer believes it's lower, so it's going to be a less than, is what we're claiming. Less than is a left tail, so we are going to shade into the left because of that. Step 2 is testing at the 5%, so alpha is 0.05. Our test statistic is a Z. Our p hat is 174 out of the 200. And that comes out to be 0.87. So we have 0.87 minus 0.92 divided by 0.92 times 1 minus 0.92 divided by the sample size of 200. Then our step 4, it's right there. It's going to be our p-value once we find it. So that's going to come from the program. And we're going to compare that to 0.05. So your 6 steps should look like this every time you do a hypothesis test. So let's go ahead and run the program. So up here, sample size is 200. our p hat was 0.87. P0 is 9.92. There is our test statistic, a negative 2.606. Don't have to worry about alpha. And then we're going down here. This is a left-tailed, so we're looking at a less than. And there is our p-value, 0.00457 or 0045. Or actually, it'd be 0046 if you round it, but okay. So let's go back to our paper. We have our p-value. So our p-value is definitely less than alpha. So we do reject H0. So there is sufficient evidence to support the claim that the proportion of U.S. adults using cell phones is less than 92%. So here's our 6 steps that you should be using. Okay, our last example for chapter 8. A poll done for Newsweek found that 13% of Americans have seen or sensed the presence of an angel. A contingent doubts that the percent is really that high. It conducts its own survey. Out of 76 Americans surveyed, only 2 had seen or sensed the presence of an angel. As a result of the contingent survey, would you agree with Newsweek poll? In complete sentences, also give 3 reasons why the 2 polls might give different results, and be sure to label all 6 steps. So step 1 is our hypothesis statement. Because we are talking about percentages, it's a P. They think it's 13%, but somebody else doubts that it's really that high. They think it's less than 13%. Okay. They didn't tell us what to test for our level of significance. So we always use 0.05 if that's the case. The p hat is going to be 2 out of 76, which comes out to be 0.02632. So our test statistic, we're going to we could put it all into the formula, but we're going to let the calculator do the work for us. It's a left-tailed, so we're going to shade to the left. And then we're going to compare our p-value to our alpha, which is 0.05. And we could use a critical z-value here. I'm going to go through that one with you too. So we can use p-value, or if our z0, that's our test statistic, right? If our z0 is outside in this danger zone, so less than the z of 0.05, then we will reject. Okay, so let's go to our program here. We're going to go up here. Our sample size this time was only 76. And you can see that 2 out of 76 is that 0.0263, but I'm going to just go back to the rounded that we had, 0.026632. Okay. and they think it's 0.13. And so there is our test statistic, a negative 2.688. And it's a left-tailed. And there's our p-value, 0.0036. And I want to get a critical Z. So that's inverse CDF of the normal dist, 0, 1. And it's going to be 0.05. So that's a negative 1.645 is the critical Z value. And this is example 3. Okay, so let's go back to our paper. Now that we have our critical Z value, we also have the p-value. Our p-value is less than our alpha, so we reject that way. But Alex is probably going to have you use the danger zone and the critical Z value compared to this test statistic. So I want you to learn both ways. Our test statistic is a negative 2.688. It is in the danger zone because this is the danger zone. Anything left of the critical Z value and our value, we are definitely in the critical Z value, critical danger zone. So we do reject 80. So that means step 6 says there is sufficient evidence to support the claim that fewer than 13% of Americans have seen or sensed an angel. Reach out if you have any questions or catch me back for another video.